All right, welcome to this explainer. We are skipping the fluff today and diving straight into a high-stakes exam scenario that literally costs IGCSE computer science students crucial marks every single year. We're going to be conquering base 16, binary, hexadecimal, and of course, the all-important nibbles. Let's get right into it. So consider this calculation. Denary 36 equals hexadecimal 24. Now, does that look right to you? Well, I can tell you right now, making this calculation error will immediately score you 0 marks in an exam setting. Ouch, right? It's a painfully common mistake where students try to just kind of guess base 16 conversions in their heads. They end up treating hexadecimal like basic tens and units, instead of using the proper syllabus-approved bridge.
Which brings us to Section 1, the common exam trap, and exactly why ordinary revision fails here.
You know, when you're sitting in that exam hall and staring down the clock, your brain is going to try to trick you into rushing. But guessing the hex value directly, it's a completely flawed approach and it fails catastrophically under pressure. To guarantee full marks, you need an absolutely unbreakable system, and that means using binary as a structural, mark scheme-safe bridge. This difference right here, it's literally the dividing line between an average grade and a top-tier mark.
So let's talk about Section 2, the binary nibble framework, which is basically your magic weapon. Check out how perfectly these systems align. You've got denary 0 through 15, hexadecimal 0 through F, and their binary code equivalents from 0000 all the way to 1111. Do you notice how the first 16 digits map perfectly across all three systems? It's so clean. This table isn't just reference data, it forms your ultimate cheat sheet for the entire 0478 syllabus. Seriously, once you know this sequence, the whole shebang just falls right into place.
Now, understanding the nibble is absolutely crucial to unlocking full marks on this topic. And yes, computer scientists actually named it that. A nibble is simply a 4-bit binary number that's used to represent a single hexadecimal digit. You can kind of think of it like a tightly packed 4-part building block made entirely of ones and zeros.
And if you stack 2 of those 4-bit nibbles together, you get an 8-bit binary number, which you probably know in computer science as a byte. Now pay super close attention here. In just a minute or so, I'm going to reveal the exact examiner clue that completely changes how you write these answers. But first, we really need to understand exactly how we stack these nibbles together to build that bridge.
All right, moving on to Section 3, denary to hexadecimal. Let's build that bridge.
Let's take a really straightforward example directly from our source material, converting denary 16 into hexadecimal. For step 1, you look at denary 16 as resulting in a combination of the digit 1 and the digit 0. Step 2, you grab the binary for 1, which is the nibble 0001. Step 3, grab the binary for 0, which is the nibble 0000. Then step 4, just stack them side by side. You literally combine those nibbles to get hexadecimal 10. See, it's just a clean, totally logical translation.
But what about larger numbers? How do we confidently convert a much bigger denary number, like 75, into hexadecimal? Because this is exactly the kind of calculation that catches out students who skip the binary step and try to just do the math in their heads.
This example brilliantly illustrates the exact step-by-step red pen logic an examiner is actively looking for when they award full marks. Okay, step 1. Find the 8-bit binary for 75, which gives us 0101011. Step 2, you split that byte right down the middle into 2 distinct nibbles, 0100 and 1011. Step 3, convert each of those nibbles to hex using our trusty cheat sheet. So 0100 is 4 and 1011 is B. Step 4, combine them for your final unshakable answer, 4B. Boom, full marks.
Now let's flip it in Section 4, hexadecimal to denary, where we'll be reversing the mechanism.
Because that binary bridge, it's totally a two-way street. So, to convert the hexadecimal number 3C back into denary, step 1 is to separate that hex 3C into its individual parts, 3 and C. For step 2, you convert those digits back into their binary nibbles. The 3 becomes 0011, and the C becomes 1100. Step 3, squeeze them back together into a single 8-bit binary byte. And finally, step 4, we deploy the place value method to find our final number.
So, the absolutely crucial point here is using this place value layout. Notice that top row of columns, 128, 64, 32, 16, 8, 4, 2, and 1. We just map those right over our combined binary nibbles, 0011,
1100. Now, wherever there is a 1 in the binary code, you essentially activate that top number. So we add 32, 16, 8, and 4 together to safely arrive at exactly 60. By doing this, you are visually proving your math to the examiner. They love to see it.
All right, on to Section 5, the IGCSE Exam Challenge. It's time to test your mark scheme thinking.
Okay, here is your challenge. Convert the hexadecimal number 50F into denary, using binary to help you. Seriously, go ahead and pause the explainer right now. Grab some paper and actually write out the steps for this specific past paper style question. Prove to yourself that this bridge really works.
All right, you back? Here is the correct working out. Step 1, break it apart. 5 becomes the nibble 0101, and F becomes the nibble 1111. Step 2, combine them to create the byte 01011111. Step 3, add up the place values wherever you see a 1. That's going to be 64 plus 16 plus 8 plus 4 plus 2 plus 1. And step 4, your final denary answer is 95. If you successfully use the binary bridge instead of skipping steps, give yourself a massive pat on the back. You are successfully thinking exactly like a Cambridge examiner.
Now, just writing down 95 with 0 working out might feel fast in the moment, but showing the actual binary bridge calculation is what actually guarantees you those marks. It explicitly answers the command phrase in the prompt, using binary to help you. Remember that examiner clue I teased earlier? That phrase was it. If you ignore that instruction and don't show the binary, you lose the marks, even with the completely right math. So always, always show the bridge.
As the educational experts from our source texts emphasize, structured methodologies like this are exactly how you ace this syllabus. By the way, they highly recommend checking out and subscribing to the YouTube channel Ace the Exams at acetheexams_IGCSE for more crucial strategies to really excel in your Cambridge examinations. But before we go, I want to leave you with this somewhat provocative thought as we wrap up. What happens when the Nibble framework just isn't enough? Like, what happens when you are staring down the clock, reading super complex scenarios, and you realize you need a fully timed answer writing system just to survive paper 2? Well, the patterns we learned today definitely continue, but to truly bulletproof your computer science grade, mastering those time strategies has to be your very next step. So, keep bridging those numbers, keep showing your workings, and I'll see you in the next explainer.